Hello ladies and gentlemen, welcome to our 7th grade semester 1 exam review. Today we'll be doing some problems together like the ones you'll see on your exam. I appreciate you guys tuning in because it shows that you actually care about your math grade, and that's always a good thing. We need to go over a few rules first before we jump right into it. They're pretty easy, only 2 rules. The first thing, make sure you show your work in order to better understand the problems. If you don't show your work and you're just watching this to kind of get the answers, I mean, that's not really teaching you anything. So make sure you're actually doing these problems with me. And the other thing is, try them on your own first. Don't just like I said, look for the answers. Make sure you're trying these things on your own, and pause when I tell you to pause. I'll give you a chance to pause it right before I show you how to do each problem. So when the problem pops up and I tell you to pause it, make sure you pause it. That's all for the rules. We're going to get started here. Make sure you grab some popcorn, your favorite scientific calculator. Let's begin. Alright, we're going to start off basic, starting all the way back at chapter 1 from the beginning of the year. First problem is just written right there. I'm not going to read each one, so just make sure when I tell you to pause, and you can go ahead and do that. Pause your screen and see if you can solve this one on your own. As you can see here, we drew a number line, and I kind of highlighted the integers that we had in our question. If you look, we always know on a number line, the farther to the left we go, which is, of course, this way. The farther to the left we go, the lower the number is going to be, the less the number is going to be. And the farther to the right we go, the greater the number, or the bigger the number is going to be. So if we look at our number line, we can see our answers right down here. -5, -3, 4, 5 is how we would order these from least to greatest. Alright, here's problem number 2. Go ahead and pause your video and try to figure this one out. Alright, so all you do for this one is remembering our order of operations. We do parentheses first. 6 minus 1 is 5, and then after that we just do 4 times 5, because the 4 and the 5 are next to each other. Or you can even look at it as -4 times 5, so we leave the minus sign here. So we got 13 minus 20, and we get -7. Next question, go ahead and pause your screen and read this one and try to figure it out. Alright, so on these type of problems, what you want to do here is you want to look at the end result, and you can see we've highlighted that there. It says the result was 63, and we literally want to take the important parts, the operations that were done to that result, to get that result, and we want to work backwards. So we know that he ends up with 63, so that's where we want to start at. And what he did is the first thing he did was multiply, so we know we're going to have to do the opposite of that. And the second thing he did was add 8. So what we're going to do, instead of adding 8 to work backwards, we're going to subtract 8, because that's the last thing he did before he got 63, is he added 8. So we're going to subtract 8. When we do that, we get 55. And then before he added 8, he multiplied by 5. So we're going to do the opposite of multiplying by 5, and we're going to divide by 5. So we take that 55 divided by 5, and we get our answer, which is 11. And if you plug that back in, that actually works. If you take 11, multiply it by 5, and then add 8, you do get 63. So on those type of problems, just make sure you work backwards. Alright, here's our next question. Make sure you read it carefully and pick out the important parts, and then you may begin. So go ahead and pause. Alrighty, when you find the range of something, you're always finding what's in between them, and whenever we need to find the amount that's in between two numbers, we're literally finding the difference between those two numbers. Whenever you hear that word difference in a problem, what should always come to your mind is subtraction, because difference should always be subtraction. Whenever you hear difference, you should always think subtraction. So in this particular problem, we're just going to take the biggest mountain she ever went on, and then the smallest mountain she's ever been on, and to find the range, we just take the big number minus the small number, and we get 5,342 feet. Make sure you always label your stuff, so this is labeled as feet. Fanatics, Here's a nice one. This is actually a true story about one of the weeks in my fantasy football league. So make sure you read this question carefully and make sure you know what you're doing. And if you don't remember what an inequality is, make sure you know that, because you need to know what that means. Alright, go ahead and pause. Okay, so it says that Vincent Jackson needs to score at least 5 fantasy football points. So I made Vincent Jackson V. It doesn't matter what variable you use. You could have used any letter. I used X or whatever. I just used V because it's Vincent. What I said was Vincent Jackson had to be greater than or equal to 5 points. If you think about it, that makes sense. If he needs at least 5 points, he can get 5 points and I can still win. Or he can get more than 5 points and I can still win. So the correct symbol you should have used is greater than or equal to 5. Congratulations, if you made it this far, you just made it through Chapter 1. We're starting Chapter 2 now. It won't be as long as Chapter 1, so you can be relieved. Go ahead and pause right now to start this question. And in this problem, H is chips, not C. H is actually in the equation, not C. So H is your chips. Alright, so on this one, what you would do here is each of them are 50 cents. Each of them costs 50 cents. So you'd use your equation. It said that we had 60 cans of pop. So where our pop is, where P is, we would put 60 because we sold 60 cans of pop. And for our bags of chips, we sold 45. So where our chips are supposed to be, we put 45. And we get 50 cents times 60 actually ends up being 30, and 50 cents or 0.5, half of a dollar, times 45 actually ends up giving you 22.5. When we add those together, we get our answer, which is $52.50. Okay, next problem. Make sure you read this one carefully, and we'll go ahead and go over it in a second. Go ahead and pause. Alright, so it says you have a total of $65 to build your raft, but it also tells you already spent $13 on screws and paint. So what you need to do is go ahead and subtract out that $13 from your total of 65, which is what we did here, and we have left over 52 to spend on wood. Well, they said it's $4 for each piece of wood that you need. $4 for each piece of wood. So what you need to do is you need to take that $52 you're left over with and divide by 4 to get the total amount of pieces that you're allowed to buy. And you can actually afford to buy 13 pieces of wood. That's assuming we don't tax it. Next question. Make sure you read it carefully, pick out the important parts once again, and show your work. Go ahead and pause. Okay, so for this one, what I wanted to do was set up an equation, and I kind of show you here how we did that. I made C my cost, so C is my cost in my equation, and then I made my gallons of gas be G, so my gallons of gas is G in my equation. And if you think about this, this makes sense, because no matter what, we have to pay $15, no matter what. So here's my $15, and it's $2.25 for every gallon of gas. So I take that $2.25, multiply it by the gallons of gas I'm going to use, and then I got to add on my 15 because no matter what, I'm paying that $15. So what I could do is I could actually just go ahead and take my price I paid, which it says I paid $26.25, and I could go ahead and subtract that 15 out from that, because I know no matter what, I'm going to pay 15. So if I take $26.25, subtract out that 15, I'm left with $11.25. So that's just the amount of money that I've spent on gas, because I took out the price that I had to pay, the 15 that I had to pay automatically. So $11.25 is just the amount of money I spent on gas, and it's $2.25 a gallon. So I take that $11.25 and divide by $2.25, and I get my answer, which is 5 gallons. Okay, so for this one you're going to express each of those highlighted numbers in scientific notation. So you'll actually have two answers for this one. Go ahead and pause it and you can begin. Okay, so for this first number, what we're going to do, we need to draw out the 0 and the 4 right here, because what you do when you change the scientific notation, it's always by a power of 10, but you need to move the decimal point over until there's only one number to the left of the decimal. So right now we got a 3 to the left of the decimal, but you write out until there's only zeros left. So we have a 0, 4, and we need to draw that 4 because that is not a 0. So we go until that 4, and then we see after that there's just all zeros, so we can leave those off. Our answer is 3.04 times 10 to the 8th. And the reason that's a positive 8 is because this 3.04 is going to get bigger, and we think about a positive being bigger than a negative. So right here we have a real small number, 0.00009. We move this decimal place 1, 2, 3, 4, 5 spaces this direction to get that 9 in front, and then it's going to be to the negative 5 power because we're going to make that 9 smaller. Second problem for chapter 3. Go ahead and pause and you may begin. Okay, if you wanted to, you could have drew out the entire bracket like they would in a March Madness bracket, or you could just think about the rounds. If you have 16 teams, you're only going to have 8 games because a team plays another team, so that halves the amount. So if you have 16 teams, there's going to be 8 games when the teams all play. After the elimination, that'll cut your teams down to 8. So in the second round there will only be 4 games. After that round it will cut your teams down to 4. So in the third round, that'll be your final 4. There will be 2 games. And if you think about it, it's just like the bracket. We have the Sweet 16, there's 8 games, and in the Elite 8 there's 4 games. The Final 4, there's 2 games, and then we think about the last game. Well, there's just 1 game. If we add all those up, each of those games, we actually get 15 games. There's actually a pattern with however many teams you have in a tournament to figure out the amount of games in a one-and-out tournament. You just take the number you have and subtract 1. So if you knew there were 16 teams, it's going to be 15 games. If there's 64 teams, it's going to be 63 games. So if you can remember that pattern, it'll help you out. Moving on to chapter 4, go ahead and figure this one out on your own, please. Go ahead and pause. Okay, what I did here is I went ahead and substituted this 3/5 in for x in each of these spots. So we got 4 times 3/5, and I went ahead and made it 4 over 1, which is the same thing. 4 times 3 is 12. 1 times 5 is 5. Remember, when we multiply fractions, you just multiply across. So the tops together would be 12, and the bottoms, or the denominators, would be 5. I do the same thing with 2 times 3/5, and I get 6/5. And then I have 12/5 minus 6/5. Well, that's easy when we have the same denominator. We can just subtract the top. 12 minus 6 is 6. Leave the same denominator, and you could write it as 6/5 or 1 1/5. Alright, so on this one it says the big one was 70 inches long, and the other one was 3/5 the size of the gator. Whenever you see that word of the gator, you want to think about multiplying when you see the word of. So we take that 3/5 times 70, and we get 42. So the other gator was 42 inches, but it asks how many inches longer was the first gator. So we want to find the difference between them. We take 70 minus 42 to get the difference, and the first gator was 28 inches longer than the second one. Okay, go ahead and read this one and pause, and you can solve it. Go ahead. Alright, the key here is to find the unit rate, or how much it costs for 1 in each deal. For the 12 for 33.54, we take 33.54 divided by 12, and 1 beaker costs 2.80. For the second one, 1 beaker costs 2.77. So the better deal is actually buying 14 beakers for 38.76. Okay, this is the last question, and my video program will only let me do 15 minutes, so if you have a question on this one, make sure you see me at school or ask your math teacher. I hope you enjoyed this presentation.